Okay, so can you guys see my screen?
Yeah, we are.
Yeah, yes, yes, Shubham.
Niyati?
Yes,
Yes,
Shubham,
Shubham. Yeah,
we are able to see.
yeah.
Okay, great. So let's start then.
Yeah,
So in
hi
the
Shubham.
last class,
Good evening.
hi Rahim. Good evening. What about Kaushik? He has joined? No.
I think he'll join soon.
Not
It's
yet.
Okay, so let's start. So we'll quickly see what Cloud Formation and Systems Manager is that we covered last week. Sorry, last class. So Cloud Formation, as you are already aware, it's a infrastructure as code. You can basically describe your entire AWS architecture in the form of a code, in the form of a template, right? So you can describe it, and then every time you run it, you'll get consistent results, right? So whatever the set of resources that CloudFormation creates, that is called a stack, right? And what are the advantages of it? You can basically uh, you can version control your CloudFormation templates. You can easily roll back if at all there is an issue, right? And we have also seen certain features in CloudFormation called as chain set, right? So what chain sets are? Chain sets allow you to preview the changes before you execute them. So if, for example, if somebody has made a modification to the template and he wants to update it, so instead of directly updating the stack, what he can do is he can create a chain set and let some senior person basically review that. So when we create a chain set, it automatically tells you if we go ahead with this update, what set of resources will be modified or deleted. So if once a chain set is created and once you are comfortable with what changes you see, then you can go ahead and execute the chain set. Only when you execute the chain set, the basically modification will happen only when you execute the chain set. If you're not okay with the changes the new template is bringing to the system or to the architecture, you can reject it, you can delete the chain set, and that's what chain set is. So cloud formation template, we know, I mean it can be written in YAML or JSON. So these are the two formats in which we can write templates. And we have also seen the anatomy of a cloud formation template, that what sections we will see in a typical cloud formation template, right? AWS template format version. We have seen description section, we have seen parameter section, we have also seen mapping section, and resources section and output section. So resources section is the only section which is mandatory in a cloud formation template. So all other sections are optional. So you might see this question in the exam, that what is the what are some mandatory sections in a cloud formation template. So we should remember resources is the only mandatory section in a cloud formation template. Other sections are just optional. So it depends upon how complex that template is. So normally it would depend upon on that, but resources section is mandatory to have in each template. And systems manager, coming to systems manager, we know we have discussed few capabilities of systems manager. What those are, we have seen one important capability or feature is session manager, right? So what session manager lets you do is it lets you manage your Linux instances. You don't even need a private key to log in via SSH. Also, you don't even have to open SSH port in your security group. You can basically simply do an SSH via session manager. Okay, so other advantages, you can even manage your EC2 instances running in a private subnet. Normally, if you don't have this session manager, what you will have to do is you will have to go via Bastion host, right? So Bastion host is one such host which is placed in a public subnet which is publicly accessible. Then you would first have to log into that Bastion host. From there you have to again from there you again have to establish an SSH session internally. But session manager lets you log into instances running in private subnet even without a Bastion host, right? So the advantage is it's much more secure and it is auditable. So later on, if at all something happens, then you can actually see you know that we have event history in CloudTrail. If we have CloudTrail enabled, we can see that who basically logged into the system at what time, who established an SSH session, and so this is also very useful in case you have lost your private key. Then how do you regain access to the system? You can easily log in via session manager and replace the private key, generate a new private key. Basically you will have to generate a key pair, and then you in that .ssh folder under authorized keys you can just put that new private key and keep the public key with you. So if at all you have lost your private key, then the other way of regaining control is via session manager. So this is session manager. The other capability that we have seen is patch manager. So using patch manager, we can patch several EC2 instances in one go, right? So in patch manager, we have something called as patch baselines. So AWS has created default patch baselines for pretty much every operating system. So they have created patch baseline for Windows operating system. They have created patch baselines for Linux operating system, and maybe even for bunch of other operating system. If you are happy with those patch baselines which AWS has created, then go ahead and use them. If you're not happy with it, then you can create your custom baselines also. So when you create a custom baseline, you have to specify for for which operating system you're creating this patch baseline, and then you can specify what kind of patches will be auto approved for patching. You can specify based on classification and severity, and you can specify the number of days after which the patches will be auto approved. Okay, and we can also explicitly approve some patches, and we can also explicitly reject some patches. So maybe based on your experience of patching in lower environments, if you see that some patches might break something, then you can explicitly reject those patches in the patch baseline. You can create different patch baselines depending upon your environment, right? One patch baseline for development environment, one patch baseline, or some simply two patch baselines, one patch baseline for non-prod environment, one patch baseline for prod environment. You can auto approve patches much faster for a lower environment patch baseline. For a prod patch baseline, you can auto approve maybe a bit later. And then how do we associate patch baselines with EC2 instances? By creating something called as patch group, right? So we can tag EC2 instances. We can create a tag called patch group, and we can specify any value. Then the same patch group we can specify in the patch baseline, and that's how patch baselines gets associated with EC2 instances. And then using maintenance window, we can schedule the patching. So we can specify maybe every weekend. It's totally up to you. There is a cron scheduler there, so you can easily build it. At what frequency you want to run this automated patching, and based on that, it will patch it. And we can also do on-demand patching. So there is this option called patch now. Then when you say patch now, then you can select the instances based on either tags, or you can select the instances by selecting them manually, or by patch group, and then you can on demand also you can patch them. So we have already discussed what I mean session manager. We have discussed uh, patch manager, and then there are a bunch of other features like you can enable software inventory on your instances which are managed by SSM. Okay, so not all EC2 instances are by default managed via systems manager. In order for the system, in order for the EC2 instance to be managed via systems manager, there are some prerequisites. What are the prerequisites? One is all those EC2 instances should have SSM agent installed and running. Okay, so if SSM agent is not installed, then we will not be able to manage EC2 instances via systems manager. Then if it is already installed and running, the other prerequisite is those EC2 instances should have appropriate IAM role attached, so that SSM agent will be able to talk to systems manager service. Okay, so so two prerequisites we are aware. One is that it should have SSM agent installed and running. The other prerequisite is it should have appropriate IAM role attached. And the third thing that is also important is that see normally that SSM agent will only be able to talk to systems manager service if that EC2 instance has internet connectivity. If that EC2 instance does not have internet connectivity, then no matter whether that SSM agent is running or not, no matter whether you have attached the IAM role or not, if that EC2 instance does not have internet connectivity, this whole things will not work out. Okay, because normally these like systems manager or any AWS service, be it S3 or be it EC2. So whenever we make, say for example, even if you try to use AWS CLI tools, if you try to use AWS commands, then if that EC2 instance on which you are executing that AWS CLI commands, if that EC2 instance does not have internet connectivity, those CLI commands will not work, because normally all these basically each service normally when we interact with AWS, be it through AWS management console, be it through AWS SDK, or be it through AWS CLI, behind the scenes we are making API calls to respective services, and by default these are accessed publicly via the internet. All these API endpoints, right, these are publicly accessible and we access them via public internet. Okay, so if you have some EC2 instances in a private subnet, you do not have a NAT gateway. Okay, if you do not have a NAT gateway, then we will not be able to manage EC2 instances running in a private subnet via systems manager. So the third important prerequisite is that EC2 instance should have internet connectivity. Now the internet connectivity, I mean, can be through internet gateway or it can be through NAT gateway. It really doesn't matter. But the EC2 instances should have internet connectivity. Okay. So any doubts on this, whatever we have discussed?
So Shubham, in this case, like the Bastion host we discussed, so it will be an on-prem host or like how it would be?
Normally, Bastion host will be a host running in a public subnet with internet connectivity. Okay.
Okay. Okay, got it.
So basically, in our case, I mean, Niyati just said right in last class that we will log into some of the web servers running in public subnet. From there, we will establish SSH session. So normally, in case of Bastion host is purposely built for this purpose, for accessing some secure servers. So those, I mean, those Bastion hosts would not be running something else like a web server. So it will be purposely built for that reason only. That would have some specialized uh, firewall settings and whatnot. And they will try to make it as secure as possible. And Bastion host will only be accessible from specific IP addresses. Okay.
Got it. Okay.
So any questions from Niyati or Rahim?
No, Shubham, no.
Okay. Okay. So so now let's see. Let's discuss IPv6 in VPCs. How we can enable IPv6 on any VPC. It's quite simple. Okay. So before we do that, let's discuss some key features of IPv6. So if I type here IPv6 representation, okay. So here the IPv6 address size is 128 bits. So unlike IPv4, which is 32-bit in length, IPv6 address is 128 bits. Okay. And basically the preferred IPv6 representation is this. So basically in IPv4, you have each octet is separated by dot, right? So here we will have colon. Okay. So we will have colon where each X is the hexadecimal value of the 8 16-bit pieces. Okay. So here we have what? So here we have 8 16-bit pieces. So X is what? It X is basically nothing but 16 bits. Okay. And
16.
16 into 8 is 128. Okay.
So in IPv4 it was 8, right? Each.
Yeah. Yes.
Okay.
Yes. So in IPv4 it was 4 octets, right? So basically 8-bit separated by dot. So here in IPv6 we will have 16
16
bits
bits.
separated by
8
colon,
colon, yeah.
right? So there will be no dot here. Okay. So now here another uh, differentiating feature is that IPv6 is represented in hexadecimal notation. Okay. So uh, so basically it will range from like this. Okay. So it will range from this to this. So essentially the only thing that you have to remember is that IPv6 will contain basically IPv6 first thing is it is 128 bit in size, IPv4 is 32 bit in size,
Hmm.
and then IPv6 is represented in hexadecimal. Okay, so in hexadecimal we can have values from 0 to f. Okay, so 0 to 9 just like any decimal, and then you will have a, b, c, d, e, and f. Okay, so IPv6 is represented in hexadecimal, and then each 16 bit. So there will be 8 pairs of 16 bits. Okay, and then each pair would be separated by colon. And the other important thing is IPv6. There is no concept of private IP addresses and public IP addresses in case of IPv6. Any IPv6 address is publicly routable. Okay. So those things like we have private IP address ranges in IPv4. So that thing is doesn't exist for IPv6 because there is no scarcity of IP addresses in IPv6 because it is 128 bit in size and there will be lot of IP addresses. So we don't have this concept of private and public IP addresses in case of IPv6. So let's see how we can enable IPv6 in a VPC. It's quite simple. So what I'm going to do is let's select some region, maybe Tokyo this time, and then let's navigate to VPC. Okay, so what I will do is now I'll say create VPC. I'll give this VPC a name. Maybe this is uh, Tokyo IPv6 enabled. Okay, so this is the name of the VPC. Let's give this a CIDR block. So 172 dot, let's say what, 23.0.0/16. Okay, so by default there will be no IPv6 CIDR block attached to this VPC, but in our case we want IPv6 with this VPC. So what I would say is Amazon provided IPv6 CIDR block. So if you own any IPv6 CIDR block, then you can use your own, which is owned by you. But otherwise, then we can simply say that we are fine with the IPv6 CIDR block provided by Amazon. So just like public IPv4 addresses, you have to get it somehow. So it's not easy to. Big enterprises would have certain set of public IPv4s assigned to them. So the same goes with IPv6 because all IPv6 addresses are routable on the internet. Okay, so there's no concept of private IP addresses. So that is why you cannot simply specify whatever IPv6 address block you feel like. So either you have to stick with the IPv6 addresses which are owned by Amazon, or you can go with the IPv6 addresses which are owned by your enterprise or your organization. In our case, we don't have any IPv6 address block, so I will stick to what Amazon owns, so we can take that. And then so we can leave all these default settings as it is, and then we'll say create VPC. Okay, one thing that you have noticed here is that we don't have to specify, unlike IPv4. In IPv4 we have to specify the CIDR block, right? For IPv6 we do not have to specify any CIDR block because all the IPv6 addresses are publicly routable. So whatever Amazon owns, so they will, whatever are free, they will give it to you. So the CIDR block for IPv6 will be auto assigned based on the availability. So now let's try to create a subnet. Okay. So we'll create a subnet inside this VPC. What I'm going to do is inside which VPC I want to create a subnet in Tokyo IPv6 enabled VPC. Then we can give the subnet a name. So pub sub, let's say pub sub 1. Availability zone, let's say maybe 1A. And then here I will say 172.23 right .0.0/18. IPv6 CIDR block. Yes, uh, uh, I want an IPv6.
Shubham, just one doubt. 18 we are adding because 16 plus 2 like that you're done, right? The
Yes,
cider
yes,
block.
16 plus 2. Yes, correct.
Okay, okay, okay. Thank you.
Okay. So I will say custom IPv6 because I want IPv6 addresses as well. So I will say yes, custom IPv6. So the other thing is that you don't even have to do subnetting here. They have already decided this /64. So you don't have to calculate anything in your head. That say for example here I could have mentioned /19 also. It depends upon how many subnets I want, right? So here you don't have that flexibility. You can't choose the number of subnets that you want to break the IPv6 CIDR block. So when you say that you want to enable IPv6 CIDR block, so they would assign a random IPv6 CIDR block, whatever is available with them, and you do not have the flexibility to choose the to choose how many subnets you want to break it into. But pretty much it will have a lot of subnets. So they have already decided /64. You can't change this /64. But see, here we can choose anything. We can put 4 6 they have already given. So we just have to fill 2 digits here. So we can put 1 2. The other subnet that you want to create, you can put 1 3 or maybe something like AF or AD or AE or AB. So anything you feel like. Okay. So we can have any value from 0 to 9 or A to F, right? So F is nothing but basically 15. Okay. A and A is what? 10. So 10 in decimal is represented in hexadecimal. How? So 10 in decimal is represented in hexadecimal as A. Okay. 11 in decimal is represented in hexadecimal as B. So similarly we have 12. 12 is represented as C, and then basically 15 is represented as F. Okay. So here we don't have to do also all sort of calculation like we do for IPv4 CIDR block. We decide that how many subnets we want. So eventually we will decide that what would be the value, whether it will be slash. Say for example, in our case, we have the main CIDR block is /16. Now, if we want 4 subnets inside it, if we want to break this into 4 subnets, then we will use /18, right? If we want 8 subnets, then we will use /19, right? And if we want 16 subnets, then how many? Then what would be the? Then it will be /20, right? So here
Sorry,
you don't have to
sorry,
do this.
Shubham, can you just come again? How did you calculate this?
2 raised to n.
2 raised to n.
Yeah.
Okay.
Yes. Correct. So if we want 8 subnets, right? So two raised to n, right? 2 raised to n.
And
So what is n here? 3, right? If we want 16 subnets, then 2 raised to n. N is what? 4, right? 2 to the power 4 is 16, right?
yes.
So in order to have 16 subnets, we would require 4 additional bits, right? If the original CIDR block is /16, and if we would want 4 additional bits, then /16 would get converted to /20, right?
Mm.
So
Yes.
this is how it goes for IPv4. So in IPv6, we don't have that flexibility. We don't have to choose in how many subnets we want to break because it's large in size. Even with this default /16, you will be able to create a lot of subnets. Okay. So I will just give and assign any number here, 1 2. Okay. So this is one subnet. So subnet is being created. Okay. And then I will create another subnet, maybe inside the same VPC, and then I will say pub sub 2, Availability zone, we can say 1C this time. So 172.23.64.0 slash what 18, right? Now for this subnet also I want IPv6 addresses. So I will say custom IPv6. Last time I gave 12, so let's give 13 this time. And then let's create two private subnets here. So I'll say priv sub 1, 1A.
Shubham, while you're creating the previous one for that public subnet, you had three fields occupied and then you did slash 18. Shouldn't it be slash?
It should be slash 18, right, Kaushik? Because see, we are making this 172.23.0.0 slash 16. We are breaking this into four subnets, okay, right? So in order to break a network into four subnets, how many bits we would require? We would require 2 bits only, right? Because 2 to the power n is 4. So what is n here? N is 2, right? So in order to break a network into four subnetwork, we would require two additional bits. So we already know that in a network address, all host bits will be set to 0, right? So uh, let's see this, okay? So this is what 6, 8, right? Now 4, 4, right? So 172.23. So for these, see these two bits are now part of network address, right? Because we have taken two additional bits in order to break the network into four subnets. We have taken two additional bits. Initially, only the first two octets were representing the network part, right? Now, since we have broken it into four subnets, so that is why we have taken two additional bits, right? So now these two bits represent the network part, right? So for 2 bits, how many possible combinations we have? We have 0001, right? And anyways, you already know that for in a network address, all host bits will be set to 0. So that is why these are all 0. So 127.23. Now the other combination is 10, right? 127.23.11. So if we basically change this to decimal, what it is, what 0, it is what, it is 64, this is what 128, and this is what 192, right? So is it clear, Kaushik?
I think he left.
Okay, so let's continue here. So let's continue here, and then for this also I want an IPv6 for this subnet. So last time we have already used 1213. This time let's say AB, create a subnet. Like there is some error. So we have not given the last one. So now we can create this subnet. Similarly, what we can do is we can create last subnet here. So this is so priv subnet 2. Now this we can put any subnet here, any availability zone here. Now let's put the last CIDR block for this subnet, 172.23.192.0 slash what 18, right? So now what we'll do is custom IPv6. We've used AB for the last private subnet. Now we can use AC. So far what we have done is we we have created a VPC with IPv6 enabled, and then we created 4 subnets inside it. 2 of them we are calling as public, 2 of them we are calling as private. All these subnets are IPv6 enabled, right? So now what we'll do is we'll attach an internet gateway to this VPC. So we'll say internet access, and then the internet gateway is created. Let's attach this to our VPC. So currently it is in detached state. I will say attach to VPC, and then okay, so the internet gateway has been attached. Now what is the last part? So last part is we have to adjust the route tables. Okay, so what I'm going to do is I'll go to route tables. I will say create a route table, and let's say we'll say this is public route table. Okay, and inside which VPC I'm creating this route table. This is our custom VPC. So now this is created. Let's create a route inside this route table. What I'm going to do is I'm going to say anything we want to send out to the internet, send it to the internet gateway. Okay, so this is representation of any IPv4 address. Okay, similarly, this is the representation for any IPv6 address on the internet. So this is the representation of any IPv4 address on the internet. So if we want to send out, if we want to send, if we want to send the traffic to any IPv4 address on the internet, send it to the internet gateway. Okay. Similarly, any IPv6, if you want to connect to, or if you want to reach out to any IPv6 address on the internet, this is how we represent it. And again, we will send it to the internet gateway. Internet gateway, internet gateway supports both IPv4 and IPv6 addresses. So that is why for both type of IP addresses, we are directing the traffic to internet gateway. Internet gateway supports both IPv4 and IPv6 addresses. So what we have done is we have created 2 routes for the internet, and we have saved this. Now let's associate this route table our with our public subnets. So under subnet association, what I'll do is I'll go to edit subnet association, and then I will attach this subnet with this 2 public subnets. And okay, so this is done. Now let's try to launch an EC2 instance and see if how we can connect using IPv6 addresses now.
So Shubham, you said that all the IPv6 addresses are like publicly available, right?
Yes, yes.
Yeah. Like we are creating here public subnet and private subnet. So will that affect it? Because like if publicly available means is it like it is accessible through the internet or like how?
No, I mean, it doesn't mean that it is necessarily accessible over the internet. It simply means that these IPv6 addresses are routable on the internet. Okay. So
Okay.
what does it mean is that, for example, IPv4 in IPv4 world, we have certain private IP address ranges, right? So we already aware of 192.168 series. We are
Right.
already aware of 10.00. Then we are aware of 172.16 till 172.31, right? So these are all private IP address ranges. If any machine having a private IP address wants to communicate on the internet, they simply can't do it with with this simple IPv4 address. It has to be NATed to a public IPv4 address. Okay. So
Right.
here,
Right.
in case of IPv6, we don't have to do any network address translation. Okay. So these can be routable on the internet. The thing is, of course, we should have the so in case of coming to AWS, if for example, even for private subnets, we have enabled IPv6, and any instance that we will launch in those private subnets, those will also have IPv6 address. But just because IPv6 addresses are routable on the internet, that does not make the instances publicly accessible. Here also, again, we would require other thing. I will show you in case some EC2 instances are in a private subnet, and if we want to access them, right? So then how that comes into picture? But essentially, in short, the answer to your question is just because any instances have IPv6 addresses, that doesn't make them publicly accessible. Okay.
Okay.
And Shubham, in this case, like we would also add the security group. So, anyways, like we have the control over the connection outbound and inbound.
Yes, yes, of course, that is another layer. So if at all assume that that was the case, that when any instance have IPv6, it makes it publicly accessible, then we still have those knackles and security groups, right? So that is additional layer of
Right. Yeah.
protection.
Right, right, right.
But anyways, that is not the case. Even with security groups and knackles, even if we allow it, but if there is no route to the internet gateway, those will not be publicly accessible. Okay. So let's launch an instance now and let's see how it looks like. So I am saying launch instance and just a minute. Okay, so what I'm going to do is we'll simply select t2.micro and then we'll select the right network here and then subnet. Let's launch this in one of the public subnets. So this is pub sub 1. This is one public subnet. Auto assign public IP. Yes, please assign a public IPv4 address. Auto assign IPv6 IP. So it is disabled as per subnet setting. So here again I will say enable. So please assign both IPv4 and IPv6. See here the difference, right? They are not saying public IPv6 because all IPv6 there's no concept of public and private in case of IPv6 addresses. So I'm enabling both. Uh, Normally it's a good idea to enable this IPv4 and IPv6 setting for public subnet so that you don't have to explicitly say enable here. And then what we'll do is, and that's it for now. And let's go ahead and launch it. Add tags. Now let's say okay, no need of any tag. Configure security group. Let's create a new security group. Allow HTTP and SSH. So here SSH allowed from my IP, and then what I'm going to do is HTTP is allowed from anywhere. Sorry, not my IP, anywhere. Okay, so anywhere means any IPv4 address, any IPv6 address, right? Both. So anywhere essentially means any IPv4 and any IPv6. This is the representation of any IPv6 address. This is the representation of any IPv4 address. So I'm opening for both and then review and launch and launch. Let's create a new key pair here and I will say create a new key pair and let's give this a name. This is my Tokyo server download key pair launch instance. So let's see once it is launched, then we will see if we are able to access this machine via IPv6 address.
So the rules are like same as IPv4, but yeah, the address we can use here is IPv6, correct?
Yes, correct. So there's not much difference between IPv4 and IPv6. It's just
Okay.
that it's bigger in size and
So
then
what is what is the advantage or difference in using IPv6 rather than IPv4? Because anyways, the VPC will have IPv4 attached to it, right, Shubham?
yeah, that is the case, but you never know going forward. See, this IPv4 addresses are scarce, right? Because it's just limited to 32 bits. So basically, people have started adopting IPv6. If for some reason you need IPv6, then you can enable it. But pretty much IPv4 is still dominant. Normally you would not enable IPv6 until you have some specific requirement. Okay. So just that if you want IPv6, you can enable it, and that's
Okay.
pretty much it.
Okay.
So now we can see here some details if we look at. So we have what public IPv4 address. This is our private IPv4 address, right? And then we have what we should have. So we have now IPv6 address also. So it looks like some gibberish text, right? So it's an
Yeah.
hexadecimal and it's bigger in size. So what I will try, we will probably we will not be able to access it directly here because why? Why do you think that? Because in security group, if I scroll it down, I have just restricted it to my. If you see, let's edit the inbound rules. It is restricted to my IPv4 address only, right? So probably I will not be able to SSH if I try to connect via IPv6. But for now, what I will try to do is, mm, okay. For now, let's keep it open. Okay, I will say okay. So what we can do is for now I will say anywhere. So basically, if you may not specify any IPv6 header for an existing IPv4. Okay, so delete. So let's add it. For now, what I'm going to say is, so for now, just leave it like this, SSH. Uh, okay, and let's say SSH. When it comes to IPv4, I'm restricting it to just my IP. For now, just for simplicity's sake, I have opened SSH from any IPv6 address, and then let's save it, and let's see if we can access it via its IPv6 address. So your ISP also has to support IPv6. I believe for me that should be the case. For now, I have just copied it, and let's switch to command prompt, and then I will go to my downloads directory. What I will do is ssh-i tokyo server.pem ec2-user at this gibberish text, which is the IPv6 address, unknown error. Okay, for now let's just connect it via the IPv4 address, and we'll see to it later. So for now, just what I'm going to do is, so at least this IPv4 is working fine, and then let's try to install Apache web server. Yum install httpd-y service httpd start. Okay, so it is running now. Let's see if we can access the web server via the browser. Okay, we can do it, and let's copy the IPv6 address. Is unreachable. Okay, So looks like AWS has changed few things. This was not the case before. If this one basically network border group, I'm not sure what it is. Uh, Network border group is a unique group of zones where IPv4 and IPv6 IP addresses are advertised. Okay, so it should be fine. It could be that my ISP doesn't support IPv6. Check IPv6.
Can you ping that in the group, Shubham, so that we can try?
Okay, sure. Yeah, just a minute. So here, if we see your IPv4 address on the public internet appears to be this. Your internet service provider appears to be Vodafone in. Okay, so no IPv6 address detected. You appear to be able to browse the IPv4 address only. You will not be able to reach IPv6 only sites. Okay, so looks like that is the case. So my ISP doesn't support IPv6, but you guys try it. I will ping it here. Okay, so what you guys do is I'll ping the IPv6 address. Simply try to telnet to this on port 22 and let's see what happens. I'll copy it and I'll paste it. Can somebody share his screen? Maybe we can check together.
I'll share my screen.
Okay.
Just a moment.
Even for my browser, it says no IPv6 detected.
Do we have to put it in the web browser?
Yeah, do it. But one important thing that we have to note is for IPv6 addresses, we have to put inside square brackets. So put a square bracket at the beginning and then a closing square bracket at the end.
Okay. Over here.
Yeah, over here. Yes.
Right.
Okay.
Enter.
Yeah, enter.
Yes, it's working.
So yes, it's working. So looks like for
Kaushik.
Kaushik, the
Yeah.
ISP supports IPv6. In
Mm,
our case, none of the ISPs support IPv6. Maybe let me switch to Geo. I'm actually connected via Vodafone mobile hotspot. Maybe
Hmm.
if I switch to Geo, I think Geo supports it. So there may
Even
be
I
a
am able to access it, Shubham.
you are able to access it. Okay, great. So let me also try once. If it doesn't work, then you guys can continue this rest of the exercise. Okay, so looks like I'm already switched to Geo now. Let's see now. I will just reload this. So looks like Geo supports IPv6. So good. So now I should also be able to access it. So what I'm going to do is I'll copy it and uh,
Shubham, are you sharing your screen? I am not able to see.
oh yes, I think I have stopped it. So let me reshare it. Share screen and start sharing. So how about now? You are able to see it?
Yes.
Okay, so I have switched to Reliance Jio hotspot and then I have tested my IPv6 connectivity. So my IPv6 address is this. Okay, your ISP appears to be Reliance Jio. and then I have 10 out of 10, so I'm good for IPv6. So what I'm going to do now is I will copy this IPv6 address. Just remember that in order, if you want to access it any IPv6 address from a browser, then put square brackets, okay, around that IPv6 address. So now I am able to connect to. Now let's see if I can SSH also. So again, we'll go back to command prompt, and then I will navigate to downloads directory ssh-i tokyoserver.pem ec2-user at my IPv6 address, and then yes. So I am able to connect to this EC2 instance via its IPv6 address. So far it's pretty straightforward, nothing too complicated. For IPv6 you don't even have to decide a CIDR block. You don't even have to decide to how many networks you want to break it into, or any brain you don't have to put it. Just simply put different digits there ranging from 0 to F. So you can put anything with that. Also you can pretty much create a lot of subnets, I believe. So we have created 4 subnets so far, right? 2 of them are public, 2 of them are private. All the subnets are IPv6 enabled. But if I launch an EC2 instance in a private subnet which does not have internet connectivity via internet gateway, those EC2 instance, even those EC2 instances, even with IPv6 address, we will not be able to access them because those are in private subnets. So let's see. I will launch one instance in a private subnet. Okay. So Amazon Linux AMI, it's fine, and configure instance details, and then okay, private subnet 1 is fine. Auto assign public IP not needed, and auto assign IPv6. Yes, we need IPv6, so I will say enable, and then we'll say add storage, and this is fine. Let's give this a name tag. I will say name is what, it's a private server. Configure security group, probably the same security group is fine. HTTP allowed from any IPv4 and any IPv6 address, and SSH is restricted to a specific IP address, and an SSH is open to pretty much any IPv6 address. So I will review and launch it. Launch, and then let's select Tokyo server. So this is our private server. It's currently in pending state. Meanwhile, I am already inside this public server. Let's upload our private key to this public server. So what we will do is I will change SSH to SFTP. Okay, let's connect through IPv4 only, maybe for now, and then this is my public IPv4 address. Why that is the case? Okay, not sure whether SFTP works or not, but let's continue with this. I will try to upload this Tokyo server.pem to the public server using its IPv4 address. So Tokyo server.pem ec2-user at. I think it will not work because when I switched from Vodafone network to Geo, then my public IPv4 address got changed, and that is why I have to readjust my security group. So what we will do is under inbound rules, I will edit it again, and let's do it. So custom my IP is this, and we'll save the rules. And now let's try to do it again. Okay, let's do put Tokyo server.pem. Okay, it is being uploaded, and then it has been successfully uploaded. Now what we can do is, okay, I'm already inside, and then I should have this key here. So this is our private key, and the same private key is used for the private server as well. I'll update the permissions here. I will make this readable only to the user, only to the owner. Owner is what, EC2-user. So chmod 400 Tokyo server.pem, and then now the permissions are changed. It is only readable to the owner of this file. Who is the owner? EC2-user is the owner. Now let's try to connect to the instance running in private subnet. So what I will do is ssh-i and this key name, and then ec2-user at its private, its IPv6 address. So I will go back here and let's see what IPv6 address we have for our private server. And here this is my IPv6 address, and then I'm already inside. Okay, so here we are able to access it via the server in public subnet. In our case, this server is acting as a bastion host. Okay, so this is our bastion host. So I connected to the bastion host, and then from there I connected connected to the instance running in private subnet. And as of now, this EC2 instance does not have internet connectivity. Why it does not have internet connectivity? Because the route table attached to this subnet does not have any route to the internet gateway, right? So as of now, this instance does not have internet connectivity. So if I try to do like ping google.com, we are not going to get a response because this instance is on a private subnet, and it has no way out to the internet. Okay. So can somebody tell me how we can securely give this instance internet access?
Net gateway.
Through net
NAT
gateway.
gateway. Yes. So that is the correct answer. Okay. So let's create a NAT gateway, and then
So,
we should be.
Shubham, just one question. Yeah, this
Mhm.
private, like the EC2 instance in the private subnet, we can access it through our piece, through your computer also, because you have provided the IP address of your computer, right? I forgot
You mean to
actually.
say directly? You mean to say
Yeah,
directly
directly,
from?
direct access. Yeah.
Yeah. So as I told you, like even if an instance has an IPv6 address, we will not be able to access it directly until there is a way out to the internet. Okay. So basically, every VPC will have a will have a router. Okay, that will be a virtual router, and basically this VPC router decides or basically routes traffic in and out of the VPC based on the route tables attached, right? So there is
Right.
no route. There is no route. Uh, so whatever route table is attached to the private subnet, that route table in that route table there is no route which tells how to route traffic to the internet, right? So it doesn't matter whether the instance has IPv6 address or not. Then basically we will not be able to connect to it. Okay. So I mean, forget about security group from which IP address it allows it, because it's not reachable from the internet, right?
Right. Right.
You got my point. See,
Yeah,
if
got
there
it.
is an if for example, if I put a server, if I put an EC2 instance in a private subnet and it has no internet connectivity, and the security group attached to that instance pretty much allows all traffic. Okay, all traffic, not just TCP or HTTP. It allows all traffic from anywhere, but it would be useless because that instance is not reachable from the internet. Okay, so does this answer your question, Niyati?
Yeah, Shubham.
Okay, great. So now you guys guessed it correctly. So in order to give internet access to the instances running in private subnet, we have to use NAT gateway. Okay. So now there is one interesting part that unlike internet gateway, which supports both IPv4 and IPv6 addresses. Okay. NAT gateway only supports IPv4 addresses. Okay. So if you want to connect to any IPv6 address on the internet, if there is any machine on the internet which has an IPv6 address and you want to connect to that machine over its IPv6 address, then we will not be able to connect via NAT gateway. Okay. So it is true that when we create a NAT gateway and when we add a route, right, when we add a route, we say that anything we want to send out to the internet, send it to the NAT gateway. So that will work perfectly fine for IPv4 addresses. But if my machine would try to connect to any server on the internet which has an IPv6 address, then I will not be able to connect because NAT gateway only supports IPv4 addresses. Okay, so this is something that we have to remember. Internet gateway supports both IPv4 and IPv6 addresses. NAT gateway only supports IPv4 addresses. So if we have no use case of IPv6, we do not have IPv6 enabled on our VPC, then probably we are good with NAT gateway. But if we have IPv6 enabled in our VPC and we also connect to some IPv6 addresses on the internet, then just the NAT gateway is not enough. Okay, I will show you also. Okay, so let's for now what we'll do is we'll create a NAT gateway. So I'll navigate to VPC section and let's go ahead and create it. So where is that NAT? Okay, NAT gateway. And then I will say create NAT gateway. And let's say internet via NAT. So we are already aware that the NAT gateway should be launched in which subnet?
Public.
Public, right? So let's select one of the public subnet. So I have selected this public subnet. NAT gateway also requires an elastic IP. So I will, allocate an elastic IP. And then what we will do is we'll create this NAT gateway. So NAT gateway is being created. Once it is created, then I will basically modify the route table associated with private subnets. And in that route table, I will add a route. I will say anything you want to send out to the internet, send it to the NAT gateway. Okay.
So, Shubham, just a query like even in case of VPC pairing for IPv6, if we use in case of that, there are no other things which we need to keep be aware of.
Actually, I haven't tried peering two VPCs which had IPv6 enabled, but
Okay.
of course you have to consider that thing in mind. So there will be an
Mhm.
additional routes in on both sides. In both the sides, the route tables have to adjusted accordingly for IPv6 also. Okay.
Got it. Okay.
Okay. So this is now available, and now let's try to adjust the route tables. I will go to route table. And since we have not created explicitly a route table for private subnets, that means currently our private subnets are associated with the main route table. Okay. So what is the main route table? So this is the main route table. So what I'm going to do is I will modify the routes here. I will say edit routes and I will say anything we want to send out to the internet. So this is basically this is sorry, this is what, this is a representation of any IPv6 address. Okay, and we are already aware that that NAT gateways does not support IPv6 addresses. So there is no point in sending the traffic to NAT gateway. I'm not sure whether it will throw an error or not. Let's normally it should, but let's see if that is the case. Okay. So basically, looks like there is some error. Okay. So maybe it's not very friendly error, but still there is an error. So we can't direct all IPv6 address to a NAT gateway. Okay, because it doesn't support it. So what I'm going to do is, so this is the representation of any IPv4 address on the internet. So if you want to send out, if you want to send out traffic to any IPv4 address on the internet, then send it to the NAT gateway. So where is NAT gateway? This is the NAT gateway. And now if I try to save it, there should be no error. Okay. So now we have given internet access to this private machine via the NAT gateway. It's only in outbound internet access. This machine can connect to any machine on the internet, but no machine on the internet can connect to this EC2 instance. This is only one way. Okay. So now if I try to do ping google.com, I'm getting a response. Okay. Just to show you guys that NAT gateway does not support IPv6. If I try to do ping 6 google.com, it's not going to work. Okay. So this ping is for pinging IPv4 address of google.com. If you use ping 6, it is going to ping the IPv6 address of google.com. So apparently looks like this is the IPv6 address of google.com. Okay, and this is not going through because NAT gateway doesn't support IPv6. So now here comes this egress only gateway. Okay, so let's see if at all we want to give IPv6 connectivity to instances running in private subnet, then how can we give secure internet access for IPv6 machines? How we can do it? If we want to connect to any IPv6 address on the internet, then then we can give it via egress only gateway. Okay, so egress only gateway is the same thing as a NAT gateway, but it is for IPv6. Okay, it is only for IPv6. So what I'm going to do now is, so there is this egress only internet gateway. Okay, so the name suggests what, it's egress only internet gateway. So basically only outbound internet access is allowed. There's no inbound. Inbound would be ingress. Okay, so the name suggests it's quite a innovative name. So egress only internet gateway, it essentially means that it only allows outbound internet connectivity, and via this egress only gateway there is no ingress internet connectivity. No machine on the internet would be able to connect to our EC2 instance via this egress only internet gateway. So let's create it. Create egress only internet gateway. So I will say, let's say enable IPv6 connectivity, or uh, let's say uh, okay, this is fine. Enable IPv6 connectivity. Okay, to which VPC we want to attach it, to this Tokyo VPC, right? And then we can create an egress only internet gateway. And now this is created, right? Let's see what is the status. Maybe it's already created. Let's try to edit the route table. I'll go to the route table, and it seems that this is the main route table which is associated with private subnets. So what I'm going to do now is I will edit here and I will say anything you want to send out to any IPv6 address on the internet, send it to the egress only internet gateway. Okay, so this is the egress only internet gateway, and this is the egress only internet gateway that we just created. So we are directing all IPv6 traffic to this egress only gateway, and I will save it. And now
So
let's
this,
see if we are, yes, what
yeah.
is it?
So when this egress only internet gateways doesn't support IPv4, it only supports IPv6.
Yes, that is true. Otherwise, there will be no, I mean, people would simply use egress only gateway. So
Right,
it is
right.
essentially
Okay.
same as NAT gateway, but it is exclusively for IPv6 addresses. Okay. So now let's try to do ping6 google.com. So now you can see we are able to get a response from google.com. So any doubts on what egress only internet gateway is or how to enable IPv6 for a VPC?
No,
It's pretty
Shubham. Yeah,
straightforward, right?
we are good.
Okay,
Yeah,
good.
Yeah. Egress is something which NAT gateway does for IPv4.
Yes, yes, correct. Yes.
same. Yeah.
So now, so this is done. What I'm going to show you now is if at all you want to, if you want to capture the logs, if you want to capture the network traffic, which is basically coming and leaving out of your VPC, as of now, we have no visibility of what network or what set of IP addresses are trying to connect to our EC2 instances, right? So could be like somebody is launching some kind of malicious attack. So normally, as by default, we don't have any visibility as such that from what set of IP addresses we are getting connections or what kind of traffic is being rejected by the NACL or by the security group or what kind of traffic is being accepted. We have no such visibility. So if you want to get some visibility on what kind of network traffic we are seeing on our VPC, right? So then there is something called as VPC flow log. We can enable VPC flow log on an entire VPC or for a specific subnet, okay, or for a specific network interface also. So let's see how we can do it. For now, what I'm going to do is, let's say, okay, Asia Pacific, Osaka. So this region we have never used before, and this should contain just one default VPC, which is already there. So I'll show you for a default VPC. It doesn't really matter whether the steps remains the same. So it's not like if you're enabling VPC flow logs for a custom VPC, it would be different. It will not be different at all. So let's see. Uh, so what I'm going to do is, okay, let's launch an EC2 instance first, and hopefully when we try to do some activity, we should see the logs somewhere in some time. For now, let's see how we can enable VPC flow logs. If at all you want to, let's discuss it formally first. Where is that? VPC flow logs. So VPC flow logs is a feature that enables you to capture information about the IP traffic going to and from network interfaces in your VPC. Okay. Flow log data can be published to CloudWatch logs or Amazon S3. So flow logs can help you with a number of tasks such as diagnosing overly restrictive security group rules, monitoring the traffic that is reaching your instance, and determining the direction of the traffic to and from the network interfaces, right? So essentially, whenever we launch an EC2 instance, it will also have some network interface attached to it. So if you want to, diagnose, if you want to monitor what kind of traffic is reaching our instances and what essentially at a high level, what traffic is coming in and going out of our VPC, if we want to monitor that, then we can enable VPC flow logs for that particular VPC, and the flow logs can be sent to CloudWatch logs or to an S3 bucket. It's totally up to you. So let's see how we can enable VPC flow log for a specific VPC. And so this is the default VPC. I will show you how we can enable this. So what I'm going to do here is I'll select this VPC, and here you see flow logs. Okay. And then here we have this option called create flow log. Then we can give this flow log a name. So let's say flow logs for flow logs for Osaka VPC. So now whether you want to capture what kind of traffic is being accepted, or you want to capture only what kind of traffic is being rejected, or if you want to capture all kind of traffic, be it accepted or rejected, then we can say accordingly we can select I will capture all traffic, be it accepted or rejected. And then here we have maximum aggregation interval. So if it is 10 minutes, so basically whatever, so every 10 minutes of frequency it is going to deliver basically these whatever it has captured, the flow logs, whatever network packets and whatever traffic information it has captured, then it will deliver at 10 minutes. It will aggregate over 10 minutes and then it will send it to the CloudWatch logs. So by default it's 10 minutes. You can also lower it to 1 minute. So 10 minutes is fine. And here you have this option whether you want to send it to CloudWatch logs or you want to send it to an S3 bucket. So for me, CloudWatch logs is fine. And here it is asking me for a log group, right? So where do you want VPC flow logs to deliver this data? So as of now, there is no log group created. So what I'm going to do is I will create a log group. So we are in the same region, Osaka, and then I will go to CloudWatch. Okay, and then we have this log groups, and we can create a log group here. We can give this a name. This will say flow logs from Osaka VPC. You can also set a retention period here. So it's up to you whether you want these logs that are delivered in this log group, whether you want to expire it at us after 4 weeks maybe. If you don't want to expire it, you want to manually delete it, then it's okay. You can set it to never expire, but you can accordingly, as per your organization policy, you can set this retention settings here. So for now, let's keep it never expire, and I will create this log group. Okay. So this log group has been created, and let's go back to that VPC here, destination log group. I will refresh it, and then I see one log group is there. But in order for this VPC flow logs to be able to deliver this data, it would require IAM permissions, right? So we will have to create an IAM role, and then we have to attach this IAM role with this VPC flow log, and then VPC flow log will be able to deliver the captured data to this log group. Okay. So as of now, we don't have any. I mean, we have several roles created, but these are not the roles with correct IAM permission. So here uh, we can see the IAM role must have permissions to publish to the CloudWatch log group. So here we have this link, set up permissions. If I click here, it will give me one IAM policy. Okay. So basically, when we say set up permissions, it basically it is easing the things for you. So here it is creating, I will say create a new IAM role. I will say flow logs role for for Osaka. Okay, so this is the role name and this is the policy document. Okay, so what is this? This is nothing but this is the policy document which represents this IAM policy. Okay, so if we read this, what set of actions, right? Create log group, create log stream, describe log groups, describe log streams, and put log events. So these are the set of actions. Okay, and what is the effect? Allow, right? So basically this IAM policy essentially allows creating a log group, creating a log stream, and describing log groups, describing log streams, and put log events. So this is bit too broader, but we are okay with it. If you want to restrict it, then you can restrict it to a specific log group. So for now, this is a bit wider, but we are okay with it. So I will simply say I'm creating a new IAM role, and the role name is flow logs
So
role for Osaka. Yes, what
Yeah,
is the
sorry,
question?
Shubham. Yeah. This is a piece of JSON code, right?
Yes, this is a piece of JSON code. Yes,
So
correct.
we can either ways toggle between YAML or JSON code and change the IRM role requirement
Yes.
as per
So
the policy.
basically,
Okay.
this is an IAM policy, right? And this is the
Mm-hmm.
default policy which they have, just created for you. If you are happy with it, then we can go ahead or we can edit this. Okay. So I believe
No, no, we are
IAM
happy.
policy can also be written in JSON and YAML. Okay. So, but this is you are correct. This is
Okay.
represented in JSON. Okay.
Okay.
So for now, what we are doing here is we are creating a new IAM role. And why are we creating this? So that VPC flow logs will be able to put the data inside the destination log group. So we'll say allow, and so this IAM role looks like it is created. And now if I refresh here, then we should see flow logs role for Osaka. And here we have the option. Okay, so how do you want the log record? I mean, so here this is the default format. Okay, so when you will see the data inside that log group, it will be in this format. Okay, the first thing would be the version, the second thing would be the account ID, then the interface ID, then the source address, then the destination address, then the source port and the destination port. Protocol would be like TCP, UDP and whatnot, and then action would be either accepted or rejected. Okay, so if you're fine with this default format, then we can go ahead. If you want to have a custom format, you can specify what specific attributes you think are relevant for you, and you can specifically select only those attributes. In most cases, thus the default format is fine. So it basically gives you an identification so that whenever you are interpreting this data which is sent by VPC flow logs, you would have an idea that which specific field means what. Okay, so we are okay with the default format. So I will simply say create flow log. Okay, so as we launch an EC2 instance in this VPC, and when we try to connect to it, we'll try to maybe install a web server, and when we try to access that web server via browser, then hopefully in some time it will be able to capture all those details. And in some time we should see inside that log group, if we navigate to CloudWatch logs, and if we go to that specific log group, hopefully after 10-15 minutes we should see some log data there, and it would have data about what kind of traffic was accepted, what kind of traffic was rejected. Okay, for now I'm not doing it, but this is what VPC flow logs is. There's nothing much to it. So any questions on VPC flow logs? Maybe you can do this as an exercise and see how that data looks like. Okay, so before we wrap it up, let's discuss. There are a few features left for within Systems Manager. We'll cover that and then we'll wrap it up for today. So before we discuss Systems Manager, any questions so far?
No, Shubham.
So let's discuss the remaining part for Systems Manager. Before I do that, let's launch an EC2 instance, because we want to demonstrate some functionality of Systems Manager. So what I will do is I will quickly launch an EC2 instance, and maybe in the same VPC. So hopefully we should see some traffic after some time. So I will say launch an instance, Amazon Linux 2 AMI and T2 micro, and then we only have default VPC. Auto assign public IP, yes, enable, and under IAM role we'll say this role, right? So this role, this you already know that IAM is a global service. Whatever resources we create inside IAM, those are global resources, right? So here that is why we initially created this role for some other region, but it is available here for Osaka as well, because IAM is a global service. Any users, any roles we create, that is available for all AWS regions. So this role is correct. So manage EC2 instances via Systems Manager. So I'm attaching this role with this EC2 instance, and then I will add a storage, add tags, Let's give this a name. This is a Linux server. I'll say configure security group and then maybe SSH. I will restrict to my IP and HTTP. I will open for all. Review and launch, and again there is no key pair. Let's say Osaka server, download key pair, and then launch an EC2 instance. Okay. So it is in running state. Let's navigate to Systems Manager. So I am in Systems Manager now. Okay, so let's see if it is available for use within Systems Manager. If everything is fine, then we should see under Session Manager also. If you are able to establish an SSH session via Session Manager, then pretty much you are, I mean, you're good with the setup. Okay, I just want to test it. So start session. Let's see if that is being displayed. Yes, this is being displayed. So looks like it is set up correctly and we can manage it via Systems Manager. Okay, so we can see I I'm this right. So if at all you forget your private key, what you can do is you can go to you can go to home directory of ec2-user. Then if you go to this directory, there will be a hidden directory .ssh. If I go to .ssh, then under authorized keys, so this is the public key, right? And you have the private key. Now you have lost the private key. So what you can do is you can generate a key pair again, and then you can basically put the public key here in under authorized keys and download the new private key, and then you should be able to log in with the new key. So this is just for your
So,
information. Yes, what is it?
like, is there any tool or like we can create it using the normal Linux command?
Yeah, normal Linux commands you can do it. I
Okay.
forgot. Let's see. SSH hyphen keygen hyphen type RSA. Okay. So here generating public private RSA key pair. Okay. Enter file in which to save the key. Let's see any. Let's say what new key. Enter passphrase. I don't want to put any passphrase. So here what has happened is what we got a new key pair. Okay. So what is this? This is the public key of the new key pair.
Yeah, got it.
So what we will be doing is essentially, okay, let's paste it. So this is the new public key, and this is the one you see here is the private key. So you can open this. This is copy, and we'll say paste. So this is the private key. So either you can just copy this and paste this in a notepad and have it on your local machine. And what you have to do is the public key, you have to go to authorized keys file under .ssh folder and then edit that file and put the new public key there, download the private key, and you will be able to log in with this new private key. Okay, it's plain and simple.
This is the case wherein you misplace your keys,
Yes, in
private key.
case you misplace the key, then and you want to regain control, then maybe you can log in via session manager, generate a new key pair, put the public key inside authorized key file, and then download the private key, and you should be able to log in with the new private key now. Okay.
Okay.
But then the prerequisite is what? That SSM agent is already installed and running. If SSM agent is not installed, then we have no way of getting access again. The only way out is basically create an AMI and launch another EC2 instance from the same AMI and choose a different key pair.
Okay.
Okay, so we are good with this. So this is what session manager is. Now there is one thing that is quite a good feature, which is run command. Okay, if I go to run command, so run command, what this feature is, if I say run a command, so what AWS has done is they have created a lot of they have created a lot of command documents. Okay, so under run command feature, we can execute a command document. Okay, so these are a lot of command documents that AWS has created for us for different purposes. These are nothing but, if you see, these are, I mean, for pretty much for every use case they would have created some command documents. These command documents are nothing but JSON documents written in JSON. So if there's one command document which is created by Amazon, and it applies some Ansible playbooks. Okay, and how this command document looks like, it is this big piece of code. This is not some programming language. It's just plain, it's a JSON code. Okay, but this is outside the scope that how to write these command documents. We don't have to study this. Okay, so they have several command documents, and then we can execute any command document using run command. Okay, so within systems manager we have this feature called run command, and there are a lot of command documents which AWS has created. So depending upon the use case, we can execute a command document.
What are these command documents like? If there is a use case scenario, can you just give us?
Yes, one use case scenario is, for example, let me give you one. For example, let's say we have hundreds of EC2 instances. Okay,
Mm.
and you want to, maybe you want to install, you want to do a set of operations, like you want to first you want to install HTTPD. After that you want to start HTTPD. After that you want to configure HTTPD as a service. Okay, then
Mm.
how would you do it?
This is
So you,
across multiple servers. That
yeah,
is
you have
hundreds.
to do this in hundreds of already running instances. So I mean, normally if you would say that, okay, if you're launching it for the first time, maybe we can put this under user data, right?
Mm.
So that will get automatically done. But assume those instances are already running. This is one just scenario that you have to perform certain set of tasks on hundreds of instances. So it would not be feasible. If, of course, it is possible that you can log into each of the instances via SSH, and then you can execute those commands one by one, right? But it would take a lot of time. So the other workaround is, of course, there you can use Ansible and all sort of stuff. Using Ansible also you can do it, right? But why to invest in all those tools when there is a native service available within AWS itself? So one such command document is run shell script. Okay, so if I search for run shell, so there is
Mm.
this command document called run shell script. This allows you to run shell script on n number of instances. Okay, so let's
Mm.
try to run it. For now, whatever instance that we have launched, it does not have any web server installed, nothing is running. So what we will do is we will try to install via this run command. Okay, so this is the command document, run shell script. This is, again, you can see how it is written under, if you go, if you want to just learn it. But anyways, from exam point of view, and pretty much in near future, it will not be you will not be using this, or at least you will not be creating your own command documents. Just remember what command documents are, and one use case I have given you, but there are other command documents for other use cases. So this is a very common use case called run shell script. This command document lets you run shell script on n number of instances. It can be even hundreds of instances. Okay, so let's see how we can do it. So I have selected this run shell script command document. I will say run command. And then here I can specify the shell script. Okay, specify a shell script or a command to run. So let's specify a shell script. So what I'm going to do is bin bash yum let's update the packages first, yum update -y. Then let's install Apache web server, yum install httpd-y, and then let's start Apache web server service httpd start, and let's configure httpd server as a service so that it automatically gets started whenever we reboot the OS. So it is check config httpd on, and then what else we can do? Maybe let's say yum install telnet. Okay, we are also installing telnet. So this is the shell script that I want to run. Maybe I want to run it on hundreds of instances. So what I have done is I've specified the shell script, and here if you want this shell script to be executed from a specific directory, you can specify this under working directory. I don't have any such requirement, so I'm just leaving it blank. Execution timeout, you can specify it. 36 seconds is pretty much good. It is 1 hour. So now how you can target your instances? You can target your instances via tag, okay? Or you can manually choose the instances if you feel like, or you can create a resource group. I will show you how you can create a resource group. It's quite easy. Okay, but essentially there are a lot of ways in which you can target the specific instances. Okay, either if, for example, if in this same region I would have like hundreds of instances, all would be listed here, and I would have simply clicked here and all instances would be selected. Okay, or I can say based on tags, I can say, for example, maybe I have tagged instances as per environment, and maybe I, for now I'm just doing this configuration for all the instances which are tagged with environment as development. Okay, so I can do like this also. So based on tags also I can target the instances, and on those specific instances the shell script will be executed. For now let's leave it because I just have one instance and it does not have any tags at all. So I will leave it as I will leave this, and then I will go to choose instances manually. I will select just one instance which is running, and then here, do you want to see the output? Do you want to see the output of this run of this shell script? See, normally you can stream this output of this shell script to an S3 bucket. Okay, so write command output to an S3 bucket. So you can enable it. If you don't enable it, so the output would be truncated after 2500 characters. So if it's a big output, then it's good to have this enabled, and then it's good. Let's do it maybe. So I will say enable a write command to an S3 bucket, command output to an S3 bucket, and let's say um, maybe this bucket. Okay, so whatever will be the output of this shell script, this will be sent to this bucket. Okay, and if you want to send the command output to CloudWatch logs also, we can do it. We can say enable, then we will have to specify a destination log group. I don't want to do it. If you want to be notified of via an SNS notification once this execution of this script is finished, then we can enable via SNS. So I don't want to do it, so I will leave it. Okay, and now let's see. I will say run. So we see the status here. Target is 1. The targets can be even hundreds or thousands. So currently it is in progress. Okay, so that script executed successfully. We can see targets is 1, completed is 1, overall status is success. Okay, now here we can see maybe what command document we executed. Okay, date requested, date and time we can see here. And then if I select here, I can say view output. And so basically here, this is the output. Okay, so we can see the output. We can download it also. So this is what the output looks like. Okay, so what I did was yum update. So this is updating the all the packages which is currently installed, and then here blah blah blah, this is doing updating, installing, verifying and whatnot. So basically after this got truncated. If you want to see the detailed log, you have to go to S3 bucket and download the full log. Okay. Similarly, if there will be any error, it will be logged here. Okay. So this is just not an error. It is, I am just using a deprecated version of the command. So, so basically this, what? So the command that I executed for starting this HTTPD, that is basically a deprecated version of it. So when you execute that, it basically redirects to this bin.ctl. So this is the newer version of starting any service. Okay, since I was using the old one, so it basically redirected to this one. Okay, and even the check config HTTPD on, that is also a deprecated version. It's an old version of how we enable service. So the new way of doing it is systemctl enable http.service. So it might have given a different return code. So that is why it is basically under error, but this is not an error. It went fine. Okay. So you can basically any output or any errors that will be logged, it will be delivered to S3 bucket and even CloudWatch logs. It depends upon how you have configured it. So now if everything went fine, we should be able to access the web server which is running on this instance. So let's try to do it. I'll go to EC2. And let's copy the public IP address and we'll paste it here. And we can see the default web server page. That means that shell script executed successfully. Okay. So now we have covered a lot of things here, right? So systems manager, we have seen session manager inside it. We have seen software inventory. We can enable software inventory on the resources which are managed via systems manager. We have also seen patch manager, right? So we can do OS patching on Windows and Linux systems and pretty much in other flavors of Linux also. So patch manager is another important functionality within systems manager. Then another important thing is run command. So run command is another feature within systems manager which lets you execute lot of command documents on lot of instances. We have seen one use case which is for run shell script. If you want to maybe configure a lot of instances at one shot, it's quite easy to do it via systems manager. No no third party software is needed like Ansible or Chef or Puppet. We don't need to do all that complex stuff. We can easily do it via systems manager. And one last feature that I would like to cover is parameter store. This is also important from exam point of view. It's quite a simple feature. Let's see what it is. Okay. So parameter store. Okay. So parameter store is a capability of AWS Systems Manager, and it provides secure hierarchical storage for configuration data and secrets. You can store data such as passwords, database strings, Amazon machine image IDs, and license code as parameter values. You can store values as plain text or encrypted data, and you can reference these parameters in your scripts, commands, and SSM documents. So what this essentially means is in Systems Manager, there is a uh, Systems Manager has a capability called as parameter store. Inside this parameter store, you can create several parameters. Okay. And then that the value of those parameters can be anything. Okay. For example, maybe in a lot of cloud formation templates, I am hard coding a AMI ID. Maybe we have our AMI ID. There are some internal guidelines from the organization that any EC2 instance that you launch should be launched from that this particular AMI ID, and that is why you have hard coded that AMI ID on a lot of cloud formation templates. Okay, but maybe they have you know there was some audit that happened or new vulnerabilities were discovered, and they fixed those vulnerabilities and they have created a new AMI, and now they have told you that okay boss, this is the new AMI ID. Now going forward all instances should be launched from this new AMI ID. Now what would be the problem? That since this old AMI ID is hard coded in a lot of cloud formation templates, you have to go and edit all of them, right? you have to change in n number of places. So instead, what we can do is under Systems Manager parameter store, we can create a parameter called maybe preferred AMI ID or maybe approved AMI ID, whatever it is. And there we can put the AMI ID which is approved from our maybe whatever, maybe from our security officer. And then we can, instead of hard coding the AMI ID in this all those CloudFormation templates, we can reference this. We can reference this parameter that we have created inside parameter store. So if at any time we have to update the AMI ID, we will simply come to parameter store. Will change the value of that approved AMI ID, and we don't have to change it in n number of places. Okay, so this is just one use case of it. You can also store any pretty much anything. So uh, any any secret codes that you want to put it, maybe any, for example, uh, maybe there is some generic user ID that pretty much everybody uses. Okay, so you can put that username and password under parameter store. Okay, so whenever somebody has to log in to that, maybe there is some sandbox server, or and we don't have individual user IDs. We simply have one generic user ID which pretty much every team member uses. Then what we can do is we can come to parameter store. We can create a parameter there, right? So there will be the name of the parameter would be username or username for so and so server. The value would be the password of that. So anybody can come here and view the password and then basically log into that machine. You can anytime come and update the password. For example, maybe that password expired and some person has changed it. So he can come and again change the password in the parameter store, and then going forward other folks can actually see the updated password. It will be logged also. Why? Because it's managed via AWS. If you have CloudTrail enabled, this will be captured, that who basically updated the password, who accessed the password and whatnot. So you can store, it's pretty much up to your creativity what you want to store inside parameter store. Okay, you can also encrypt the data or the parameter value. So let's see how we can do it. So
Shubham, this is a paid service.
no, it's free. So we can see here, if we go to parameter store and if we say create parameter, so there are two tiers. One is standard. Okay, for standard there are no additional charges. Okay, so the limit is you can create up to 10,000 parameters. Parameter value size can only be up to 4 kilobytes. Okay, if you select the tier as advanced, then charges are applicable. Okay,
Okay.
so we can here we can create a parameter name. I can say maybe approved AMI ID. Okay, we can give this a description. AMI ID approved from, maybe AMI ID approved from ISM, Information Security, or ISO, Information Security Officer. So this is the name of the parameter. Name of the parameter is what? Approved hyphen AMI ID. Now what is the type? So type is what? String, string list, or secure string. So basically if you want to encrypt that value, so whenever it will be stored in encrypted format. So wherever AWS is storing, it will store it in encrypted format. Of course, when you basically when you view it, it will be decrypted. Okay, so in my case, the string is fine, and the data type here, there's normal plain text, or you can, there is, they have detected it that a lot of people use this parameter store for storing AMI ID. So there is this type. So type is AWS colon EC2 colon image, or you want to store some normal text. So maybe this is the case. We want to store some AMI ID. So what I can do is I can go to EC2 and we can try to see. So this is the AMI ID. Assume this is the AMI ID which is approved for from our information security officer. So I will put it here, and then I can say create parameter. So the parameter has been created. Similarly, we can create a parameter for some maybe database or some even some server. Like we'll say this is, we'll say This is admin password. So here it's a secure string. Okay. Now, um, so here, if you can also store the data in encrypted format. If you want to store data in encrypted format, you have to specify a KMS key. So KMS is key management service. Inside this key management service, you can create a customer managed key, and using that key, you can encrypt the data. Okay, but we can choose the default key. This key is managed by AWS. AWS has control of it. Okay, so we can encrypt using the default AWS key. We don't have to pay for it. But if you create a custom key inside KMS, then you can specify that custom key, and then you will have much greater control over that key. So in my case, I don't want to be bothered with it. So if I would have created a KMS key in Osaka, I would have this option to choose that customer managed key. So this is the default key. So this key is fine with me, and I will say, and we can see maybe this is super secret. So we have created two parameters inside this parameter store. So this is the last feature that I wanted to cover for systems manager. So so any doubts so far from last class or today's class?
No, Shubham.
For today's class, we'll practice, and if there is any, will
So,
yeah.
so Shubham, VPC endpoint you will cover later on, right?
Yeah, I will cover later. Yes, next
Yeah.
class
So we
because
are,
it's already too late.
yeah. For today we are good. I mean, we don't have any. I don't have any doubt.
Shubham, before we leave, let's discuss about next week, like what timing will be
Yeah,
okay
correct.
for you.
Okay, so I am fine with I mean the same timing, 7 to 9 or 9:30 depends. So what about you guys?
Mm, for me also, it's fine.
Yeah, we thought like you will be doing night shift, so we can plan for early morning session maybe or
No,
11
but
to
I
1.
think Rim,
Yeah,
he will like need some sleep. So let's
correct,
have
correct.
this only.
Yeah,
Then we are fine with it at the same time. We forgot
Yeah,
that.
actually this
Sorry.
timing suits good because
Yeah.
mostly I would be slept well, and then seven is perfectly fine with me.
Okay.
And mostly I think at max we will have three more classes, and then in so hopefully by next Friday we will be over with this classes, and then maybe there might be after these three classes are over, there might be few small, I mean not very important topics that might be left. So but those might not be very important from exam perspective. If you just cover what we have covered in this session, then I think you would be able to pass it, of course with a good score. But there might be few things which are not very important, they may ask you, because there are close to 65 questions. So maybe in the last class we'll discuss some kind of important concepts that you should remember. But normally in three more classes we should be able to finish this. And if at all after this class is over, if at all you guys have any doubts, then you can reach out to me personally. Okay.
Sure, sure.
and Shubham, so you will also be providing us with the mock exam, right?
Yeah. So Rajesh has access to a portal that has lot of practice tests. So to pass, if the important thing is, if for you guys, the important thing is to pass the exam first, then practice a lot of practice tests. It may happen that few of the questions may go wrong. Just review why it went wrong. The explanation would also be given in that, and then once you practice a lot, then it would be just a cakewalk for you. Okay.
Yeah.
Okay.
Okay then. Okay then.
All
Have a
right.
nice.
Thank
Thank you, Shivam.
Thank
Yeah.
you.
Thank
Yeah. Have a good
By
day,
any
guys.
Have a good
chance,
night.
yeah, you too. By
Yeah.
any chance, you want to have a class this weekend or Friday? Because this week we could not. I mean, uh, we didn't take one class that which was
Yeah,
supposed to happen
we
on
can have
Monday.
we can take tomorrow, right? As
Yeah, we can have it tomorrow.
Yeah,
We can have
tomorrow.
Uh,
it tomorrow, right?
Yeah, yeah.
tomorrow, can we just have for? Can I confirm in a while, please? Because I probably have some activities lined up as it is Friday night, right? So we have some migrations which are going on. I'll just confirm in a while. I'll just ping in the group.
Yeah, sure. If that is
Or
not possible, maybe we can
Saturday.
have on Saturday.
Yeah,
Yeah.
Oh,
Saturday also is fine.
Yeah. Even
Okay,
I'm okay
so
with Saturday. Yeah.
yeah, so Saturday, yeah. So let's decide. So you guys decide and then let me know
Yeah.
in
We'll
the group. Okay.
confirm group. Yeah. Yeah, Shubham.
Yeah,
perfect.
sure.
Yeah,
Thank
Okay
you.
then. Yeah. Thanks everyone.
yeah.
Bye bye.
Thanks. Yeah, see ya.
Thanks, Shubham. Yeah, bye. Good night.